Try answers. This strategy really comes in handy when you have a question that you could solve with algebra, but you've had enough algebra for one day. So try answers in particular is really good for algebra questions with numbers in the answers. If you have variables in your answers, you might want to check pick numbers. Okay, so you'll know try answers when you see it, and we'll look at a few examples. But I'm going to explain kind of the two main approaches to try answers. And I'll start with the more common one, which is start in the middle. And this is usually what you want to do. So as you probably know, there are 4 answer choices, but what you might not have noticed is that they're always written from either lowest to biggest or from biggest to lowest. So they're always in order. Meaning if I start with a middle answer choice, let's say B, I could also do C. Let's say I do B, and this thing is written from lowest to biggest. In that case, if I plug in B and it doesn't work, then too bad. But let's say that I think a little bit harder about it, and I realize that B was too big. Well, if B was too big, then C and D, which are even bigger, are just going to be even farther off, meaning we already know the answer is A. Wow, that was pretty quick, right? Let's say, on the other hand, I plug in B and it doesn't work, and it's too small. In that case, A must be way too small, and it's either C or D, and we just got to check it. Of course, there is also the possibility that I just plug in B and it works. Hooray. Okay, so that is what you usually want to do. In some cases, you're going to want to start at the extreme. So that's either the lowest or the biggest answer, depending on the question. So some keywords for this would be something like greatest, least, and so on. And also there's synonyms. So greatest, maybe maximum, least could be minimum, and you get the picture. So again, there are 4 answer choices. Let's say E, F, G, and H this time. And let's pretend the question is something like, what is the maximum number of chocolate bars that Alex could eat? And I'm pretty sure the answer to that question is like infinitely many. But let's just pretend there are 4 finite options, and they're asking for the maximum. So I would start at H, again, assuming that this is written from lowest to biggest. So I would start with H, and if H works, then great, because that's the biggest number out of the options. And if it works, I'm just going to take their word that that must be the maximum value. If it doesn't work, I would just go on to G and try the next biggest and kind of continue like that until I find the answer. Okay, so that's try answers. Let's look at a few examples. I'm going to show a few examples here. Feel free to pause the video whenever you see a new problem and try to solve it on your own. Push play whenever you're ready to see the explanation. All right, let's dive in. The sum of the numbers A, B, and C is 68. The ratio of A to B is 3 to 5, and the ratio of B to C is 5 to 9. What is the value of A? Okay, there are numbers in the answer choices. Let's try answers. I'm first just going to get this information they gave us on the board. So A to B is a 3 to 5 ratio, and B to C is a 5 to 9 ratio. Okay, I'm going to try something in the middle to start. How about 6? So I'm saying A equals 6. So let's figure out what the other values would be, B and C. Well, the ratio of A to B is 3 to 5. A is 6, which is 3 times 2, so B would be 5 times 2, and that's 10. And the ratio of B to C is 5 to 9. 10 is 5 times 2, so C would be 9 times 2, and that's 18. So let's see, do they have a sum of 68? 18 plus 10 plus 6. Not even close. They have a sum of 34, which is way too small. Oops. Way too small. Okay, so 6 is not the answer. And rather than going ahead and trying 3 next, which is just going to be even farther off, I'm going to try a much bigger value this time and try 12. So I'm saying A equals 12. Okay, so the ratio of A to B is 3 to 5. 12 is 3 times 4, so B will be 5 times 4, and that's 20. The ratio of B to C is 5 to 9. 20 is 5 times 4, so C will be 9 times 4, and that's 36. All right, let's see their sum. 12, 20, 36. What do you know? They have a sum of 68, so 12 was the answer. Let's say instead of trying 12 after I tried 6, I went to 9. I would have seen that that's not the answer and that it's still too small, so then we still would have known that 12 is what we're looking for. At Tatiana's yoga studio, she has two options. Option 1 is to pay $11.50 per yoga class, and option 2 is to pay $200 for unlimited yoga classes. What is the minimum number of yoga classes Tatiana must attend for option 2 to cost less than option 1? Numbers in the answer choices, so let's try answers. This time though, I'm not going to start in the middle. There's this keyword minimum here. So multiple answers might have option 2 costing less than option 1, but we want the very smallest value for which that's true. I'm going to start with the smallest value they gave us, 17. So option 2 is going to cost $200 no matter what. Option 1, that would cost $11.50 per class times 17 classes. What is that? I'm going to write 11.5 times 17. And it looks like we get 1955. There's one digit behind a decimal point in the multiplication, so the decimal point goes there. That's $195.50. Very close to 200, but option 1 still costs less than option 2. We want the other way around, so A is not the answer. It is very, very, very close though. So I've got a good feeling that if we added just one more class, we'd probably get over 200. I've got a good feeling about B, and we're going to try 18 next. I'm going to use the work that we already did and just add one class, one $11.50 class to the 17 we already calculated. What is that? All right, we get $207. That is more than the 200 from option 2, and B is our answer. If x is greater than 0 and 2x squared plus 5x equals 33, what is the value of x? This is an algebra equation that you could solve if you know the quadratic formula or factoring, neither of which you're expected to know at this point in your math career. So let's try answers instead. I'll start in the middle and I'll try x equals 2. So what's the value of this expression 2x squared plus 5x when x equals 2? Let's see. 2 times 2 squared plus 5 times 2. Using PEMDAS, let's do this exponent first. So that's 2 times 4 plus 5 times 2. We'll do the multiplication first. 8 plus 10 is 18. So, womp, we wanted 33, but we got 18. 2 is not the answer. And I'm also noticing that the bigger that x is, the bigger that this expression 2x squared plus 5x will be. So 18, the result when x was 2, is too small. I'm going to try a bigger value of x this time. How about x equals 3? So what's the value of 2x squared plus 5x when x equals 3? That's 2 times 3 squared plus 5 times 3. 2 times 9 plus 5 times 3. That would be 18 plus 15. Now let's see what that is. Drum roll, please. We get 33. That's exactly what we wanted. Everything checks out when x equals 3. So that's the answer.